Welcome to Slight Reliability, the show where we learn SRE and observability 1 week at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability 1 week at a time. Today, I am joined again by Kyle Forster, who you may recognize from episode 32, where he and his colleague Shay Stewart talked with me about the concept of social reliability engineering. But today, we're talking about AI. Before we get into that, a little bit about Kyle. Kyle left the Kubernetes team at Google to start RunWhen, a company helping small teams who are using his former product. They blend modern AI and an expert community of SRE and DevOps engineers to help anyone answer the question, what do I run when? The company released their first open source tool in early July and saw over 600 downloads in the first few weeks, and is currently focusing on a range of use cases for platform engineering, service desks, SRE pair programming, automating L0 triage reports for incident responses, and that kind of thing. Prior to Google, Kyle was the founder of one of the first companies in software-defined networking, Big Switch Networks, a company he has helped grow to over $60 million in sales before the company was acquired by Arista in 2019. Kyle has an MBA and an MS in computer science from Stanford University and undergrad in electrical engineering from Princeton, and currently holds 9 different patents in data center and wireless networking. That's a lot of there's a lot of things that you've done in your life.
It's a lot of paperwork.
So yes, as I said, you might recognize Kyle because he's been on the show before, but today we're talking about AI and some of the experiences that you've had with AI at RunWhen. But before we get into that, let's start with the basics. So when we talk about AI today, within the context of troubleshooting, what is AI? And everyone knows who listens to this podcast that I'm a bit of a skeptic. Should we be calling it AI? Or maybe is there a better term that would be more suitable?
I'm sure that there's a formal definition for it, but I think of AI as, I think if you Google it, some of the first hits say that the process of a machine trying to emulate human thought. And then if you talk about machine learning, then it's basically advanced statistics. And I suspect like one term kind of overshoots the situation and one term kind of undershoots the situation. If we called it like really advanced statistics, this whole podcast probably wouldn't be happening at the moment anyways. I remember very well, actually, in grad school, I had this one professor who taught the stochastic methods class. And he would have like 6 or 7 people sign up for it. And the AI class was like 70 people signing up. And as far as he was concerned, that was pretty fantastic. That was far fewer pesky grad students that he had to deal with. So let's pick what kind of success we want.
Yeah, I like that, advanced statistics, because that for me sounds more closer to the truth, I guess, in terms of what we're building and what it's doing. Well, you mentioned machine learning there. I asked my colleagues at Squared Up internally what questions they had about AI. And one of them was, where do you draw the line between AI and machine learning? And that's from my colleague, Tim Wheeler, who's also been on the show.
I generally don't. I mean, these are kind of both marketing terms on top of a lot of kind of vendor popularity, on top of a lot of layers before you actually get down to the original academic research that underpins both of these areas or this general area. I think because of the way that generative AI and look, ChatGPT being the first product to ever hit 100 million users, I think unfortunately in the industry we'll have a whole hype cycle around AI being chat and being chatbots. I really hope that hype cycle flushes through fairly quickly. I think that generative AI is an amazing, amazing thing for a lot of us, but for reasons that are not entirely obvious. And I think, unfortunately, most vendors at the moment are using it to create lots and lots of chatbots. My ISP has a chatbot for customer service. They've had it for 5 years. I hate dealing with it. It's awful. It consistently tells me in perfect natural language that it can't really help me with my basic request, just cancel a couple of services, and then it sends a very perfectly worded apology. It's not very useful. I actually think that there are amazing applications of generative AI that don't have much to do with these natural language chatbots, but the industry has to digest this whole chatbot wave first.
It might be a dumb question, but what do you mean exactly by generative AI? Is it just AI or advanced statistics which create stuff? Like, what is it?
So I think of generative AI specifically being, let's call it things like OpenAI, things like Bard. Let's just define it by a series of examples first. Falcon, Llama, these very, very large language models that have been trained on gigantic corpuses of text that have the ability to, whether it's exposed as an endpoint or exposed as something else, you give it a snippet of text, and then it responds to you with a completion. So let's just call that generative AI. That's using a very, very, very large AI model to say, given a couple of sentences, predict 8, 9, or 20 sentences that would come next. The most obvious application that I think a lot of people glommed on very quickly because of ChatGPT was, hey, ask a question in natural language and receive a response in natural language. The chatbot. Now, can these chatbots do really interesting things? I asked ChatGPT, hey, it wasn't so interesting because it was a chatbot. It was really interesting because it did awesome web search. You would ask it a question. It was really, really good at taking that question effectively under the hood, framing that question like a web search, doing a web search, and then summarizing the results. I worked at Google. I loved actually using it, at times instead of Google for basic web search functions. So I actually think that to me, the fascinating thing about it was not the natural language part. It was just that they built a better web search engine. If you look at what it takes to build web search, it's pretty fascinating, right? If you actually take search and you start ripping it apart into all of its different components, whether it's web search or other search, building LLMs is by far the most expensive part of it. You really want to get to a point where you search for database and it will return entries that never use the word database, but use the word Postgres. How did it ever know that database and Postgres, these two different strings, were related? Well, you actually get there, if you were building a real search engine, you actually get there by taking the user's query as text, and you use generative AI, the equivalent of what's now available to anybody today, to say, hey, can you just describe the intent of what the user is looking for? And you take all your search targets, which most of us are familiar with web search. You would take a web page or sections of a web page, and you would go to generative AI and you'd say, hey, can you describe the intent of the section of a web page? And when you do search, you're actually matching intent to intent. You're not actually matching the text from the query to the text from the web page.
Okay, so how much of what's happening right now, the buzz about AI, is a genuine innovation versus just hype, marketing spin? Is there something really that has changed in the last year or two, or has it been gradually happening for a long time?
I do think the sudden availability of LLMs, which were like the very, very, very hidden crown jewels of ultra large, let's just leave it as ultra large internet companies that now anybody with a credit card can swipe and have access to for $4 or $5 worth of queries. That's a big deal. That's a really, really, really big deal. I like to think that the cost of using that technology to build a chatbot or ability to build chatbots, which I don't like, hey, the cost of building a good chatbot just went down by a factor of 100. The cost of building a really good search engine just went down by a factor of 10,000. And I think that's where we'll see some really, really, really interesting innovations. Harder. It's a lot more work than building a chatbot on top of one of these LLMs. But I think that's where we're just starting to see a lot of very interesting innovation. And if you look closely at search technology, well, if you think of a recommendation engine, a recommendation is search technology. You're just forming the query differently. You're forming the query out of user behavior rather than explicit user input. I don't see a functional difference, frankly, between a search engine and a recommendation engine.
Okay.
And the next step that I think as an industry we'll start seeing after recommendation engines is these digital assistants. Forget about natural language for a second. Who cares if the digital assistant can speak natural language or not? But something that's always watching behavior and listening for your queries and is finding things for you. It's effectively continuously running search and recommendation in the background as you're doing things and coming back to you with inputs, not only from you, but from other things in the environment saying, hey, I did a search. Here's my result.
Makes you think of augmented reality, and being able to constantly look at your surroundings and provide you additional helpful information about whatever it is you're looking at or the problem you're trying to solve. Yeah,
I think that is and I think all three of these are the same technology: search, recommendations, and digital assistants. It's all the same, and that is, I think, the big area where generative AI, where these LLMs are going to have long-term impact.
One more thing before we move on to your experiences so far. One of my colleagues asked about hallucinations, and he had a specific question, and that was Simon Powell, so thanks, Simon. But I actually don't know what a hallucination is within the context of AI. So what is it?
So these large language models, they're trained on massive corpuses of text. The way they kind of work is to say, hey, given any sentence or given any combination of words, what are some very likely words that happen next? So very good at question and answering, and it looks like a question and answers. Hallucination is sometimes they kind of start going down the wrong path. You suddenly start to see that something looks very logical, like very logical language, but you realize it doesn't actually make any sense. And that's because the probability that one word follows another word, follows another word, follows another word was very, very high. But one of the words in there kind of sent the thing off in the wrong direction. So they look right. They look logical, like the text kind of, if you read it fast, you're like, oh, okay. But then you read it again, and you're like, oh boy, no, that's very far off. Now, when you ask LLMs to generate code, hallucinations are a pretty big problem because it can start going off on its own way. But when you ask it to generate something like Python or Golang or JavaScript, a human can kind of scan it pretty quickly and say, oh, okay, I see where it went off track. When you ask them to start generating things like CLI commands, it's very common that LLMs will start making up command line flags that don't exist. But they look logical. Like they look right. They look like they should exist.
Yeah, I just Googled examples of LLMs and hallucinations, and the Google immediately answered with the example of you ask an LLM for the weather report for a fictional city, and it will give it to you confidently.
Yes, and it will look logical. It'll even generate documentation for command line flags that looks right.
So there's a little bit about AI. I still think there's a lot more to unpick, more that we can cover in the 7 or so minutes we've talked about this, but that's the basics. So what have you been doing with AI at RunWhen? Because I think it's quite interesting what you've discovered. And where do you think it is strong versus where it's not necessarily as helpful as you would think it might be?
Well, when we were on the show last, we talked about our model is having an open source community, a paid community, and we pay royalties to folks in our community to contribute health checks and troubleshooting commands. When our paying users run them, we actually pay royalties. We pay bounties back to the original authors. So I have a whole thing on why I think that's fair in the future of open source, but that's just a topic for another time. We played, obviously, given our model, we played around with the idea: can we use generative AI to generate troubleshooting commands? And it was more out of morbid curiosity. It was a complete failure. I mean, we spent a huge amount of time prompt engineering, few shot learning, fine-tuning a lot, like all this crap, and none of it worked. I mean, it laughably didn't work. The thing that it was really, really good at was, given a submission from one of our authors, it was really good at generating a pretty accurate description, not quite accurate enough for us to have confidence in showing that text to the end user, but incredibly confident in us using it for metadata for search. So that somebody could suddenly search database, how do I troubleshoot this database? And it could come up with 10 scripts on how to troubleshoot Postgres. Somebody could troubleshoot database, and we could actually know in advance that person's database is MySQL, and it'll just come back with MySQL scripts. That's where it was really, really useful. And the first experiments we did in 1 week, we had written basically 3 search engines before that. 3 of us had taken a whack at writing our search engine before then. So we spent a lot of time on the search engine before then, a lot of kind of NLP work. In 1 weekend, we outperformed our search engine v3.0. And that was it. And this just worked incredibly well. We're now getting more and more sophisticated about, let's take the user's query, let's take everything else that we can see in the environment, and let's turn that into a really, really sophisticated query. So we don't just take the text from the user, we take a lot of signal from what's going on around them. And then we take a look at all these troubleshooting commands that somebody's approved for their environment. And we don't just look at the text of the troubleshooting command. We don't just look at the doc string. We look at actually what's now like 5 or 6 pages worth of data for something that's, multi-line troubleshooting command. And we do matches there to come up with really, really good search. We come up with really good recommendations. And then we can also, obviously, as I mentioned before, have these digital assistants that are constantly running, saying, hey, given what I think is happening, I really recommend you running these 5 commands right now.
Okay, so the ability to use it to understand what a particular command is doing in a way, and then build metadata around that, ultimately is allowing your product to help make recommendations on, hey, you're having this issue. What about running these commands?
What do I run when? You fill in the blank, and then it comes back and says it. Now, the big thing that we got a lot of the basics up and running. Some fascinating bits and pieces that we came up to was, hey, with a little bit of human hinting, I don't think LLMs don't do this all that well by themselves, but a little bit of human hinting from the original author that wrote the troubleshooting command, they can say, hey, the output of this command is healthy and doesn't really deserve human attention, or the output of this command actually needs further analysis and needs to be looked at. It's unhealthy or just unexpected. We're just now getting to a point where we can turn that into another search query. So a digital assistant can run a series of commands, look at the output, say, all right, I need to escalate to a human, but also given what I saw, I'm going to run 5 other commands that I think would be relevant. And it can start doing that in chain. And we call them run sessions, where you can actually set the thing off and it'll start, hey, running commands saying, is this healthy? If this wasn't healthy, here's a whole nother tree of commands that I'm going to run. And it starts to actually look like a human troubleshooting session.
Does this happen automatically? Or like, I'm just thinking if you're running Kubernetes in production and you've got this tool running all these commands and you might be asleep and you never know, like it's probably doing absolutely fine, but like is there any like risk there, or is it always a human intervention required?
I mean, I have some funny stories on the early days when, it kind of looked like a Roomba. But we discovered the hard way and pretty fast. The way at least that we have our stuff configured, we have some of our digital assistants that only have read-only access. And those are the ones where we put in most of the automation. So in the middle of the night, those are the ones that are running. Mm-hmm. Those are the ones that everybody on the team has access to, and you can ask any question, it'll track stuff down for you. And then we have, at least the way we've configured our product for our own use, we have a small number of assistants that are capable of remediation. Those a small number of people on our team have access to. And those we automate with extreme care. It's kind of nice because we suddenly manage RBAC for these digital assistants, very similar to the way that you manage RBAC for humans. We have this one model that we call Eager Edgar that has read-only, but has read-only over like pretty much everything. And you can kind of ask Eager Edgar without really thinking too much. Oh, yeah, sure, just run these 20 things, come back to me in 20 minutes and tell me what you found. Whereas Admin Alley, you don't set off to run autonomously. Let's just say we don't do that in prod.
Okay, but you see that from the start, though, that this is like a digital assistant, though. It's not meant to replace, ops engineers or anyone, engineers being involved in the process. It just helps, I guess because I talk a lot about cognitive load. I'm guessing that it really helps you to, rather than going, there's a bazillion possible things we could do here, getting a short list to say, here, I've narrowed it down to these particular things. And that gives you, I think, the human mind, even if those things are all wrong, which they're probably not, at least gives you a starting point to go, okay, let's check these things first. It's not working. That must be because of this other thing, and, go and solve the problem.
Yeah. A very, very early request that we had come in was to say, hey, we need to create really good screens that show when the assistant runs something to actually show what the underlying CLI commands that they ran were and what the actual output was. And it's a lot. I mean, if you kind of unleash one of these, they can generate 30 or 40 pages worth of CLI traces in a hurry. That's the importance of saying, hey, here's the summary. Here's what we think is actually important for a human. But the really interesting thing, I really loved it. One of the demos that we showed, this was a couple months ago, we showed it to one of our design partners and they said, wow, this is like pair programming for SREs. And that for me was kind of an aha moment. Roughly the same time, there was this paper out of Columbia University where they showed, hey, pair programming for developers trying to write a web server. When they did pair programming with an AI assistant, students that did that finished the task about 56% faster. Even though it was just AI, it was somebody that they were working with the whole time, bouncing suggestions back and forth. And I loved hearing somebody, oh, wow, okay, so this is like pair programming for SREs when somebody's kind of just getting up to speed on one part of the stack. Here are 32 ideas on what to do next. You pick, but here are 32 ideas. People get up to speed really quickly.
I hate to admit it, but this is one of those first times that we've talked about AI topics where I've been like, you know what, that sounds pretty exciting. I hate to admit it, especially given that I'm in my company the only person in New Zealand, and there's really no chance to pair program with anyone. That sounds quite appealing to someone in my position.
At Google, on most teams, it was a 6 to 12 month shadowing period for new SREs before you were on call solo. Very few companies can afford that. I mean, that was, that's a team with over 3,000 SREs. Like when you're like a team of like 3 or 4. you're onboarding somebody new. Are you really going to say you got a shot? It's a model where I think enterprise outside of the world outside of Google just needs a very, very different model to get people up to speed, because it's just impractical. These shadowing mentoring programs are amazing. They really are a feature of the industry, but they're not replicable.
Okay. I do want to move into like the future, what's coming, what do you think is happening in the future? But before, I have one more question from a colleague, Simon Powell. He wanted to know what happens in a situation where AI starts to read its own work. He gave an example of, say, Copilot generating code that's committed to GitHub, and then Copilot learns from its own code. Like, is this a concern, and does this happen, and what happens in that situation?
I just don't believe that AI writing the troubleshooting commands makes sense.
Okay.
I do believe that AI helping you select which ones to run, and even autonomously selecting which ones to run, works really, really well. And summarizing the results works really, really well. So I think it's kind of a, what are you using it for? And I think you kind of want to set the tool up for success.
Cool. That makes total sense. Yeah. Okay. So the other thing I wanted to talk about is what the future of this AI, machine learning, LLM buzz, what does it mean for the future? And once again, I asked my colleagues what they wanted to know. The one question is, what tech jobs are most at risk of being displaced by AI? And I already think I know part of the answer to this question is I don't think that AI is necessarily displacing jobs. It's more just enhancing what we do. But okay, do you think there's a risk of tech jobs being displaced by this technology?
Let me start. There's this great quote from, I think it's from Niels Bohr, like, predictions are really, really difficult, especially predictions about the future. I think in the very, very near term, look, every single one of the teams that we're talking to had a layoff in the last 12 months. So I'm not too worried about displacing jobs. I'm worried about helping teams survive when suddenly they're down 20 and 30% headcount from where they were even just a year ago. I think right now we need to figure out how do we make these teams sustainable and viable when, in addition to layoffs, there's a lot of senior engineering burnout. I mean, the total throughput of the team has gone down by much more than 30%, even though it was a 30% layoff. So I think less about displacing jobs, because the down economy already did a lot of that, and more, how can we take the average SRE and get that person to really operate like a 10x or SRE? I'll tell you, I'm a pretty average developer. And in C, where I have to manage my own memory, the results are kind of dismal. Java was a huge step forward for me in the amount of impact that I could have in my brief career as a developer. And even now, my ability to write in like Python and Go is just completely different. And having actually written in assembler, I just see the amount of impact that I can have when I get the machine to do a little bit more for me. I think with SRE, if we can get this to a point where somebody doesn't have the cognitive load of even something simple, remembering every single command line flag for what's a 3-line kube kettle call, and instead say, this is one of our favorite examples, like, show me the disk utilization underneath all of my persistent volumes. Is there anything that's just about full? And if we can remove all of that cognitive load involved in answering that question, then I think we could turn more SREs into 10Xers. I really do.
Sorry, Tim, we didn't answer your question maybe the way you wanted to. Maybe it's not that there's being particular jobs that are at risk of being displaced. It's more, it's going to help people be more effective in their jobs.
Be more effective.
Yeah. What's the next big thing after LLM's going to be?
I think it's less than the next big thing. I think it's more, how are we going to see LLMs show up? And again, I come back to where we started. Like, I think that the industry will consume the chatbot hype cycle very rapidly. And I think the shame of it is, I think that there's a very real chance after vendors launch their chatbot interfaces over the course of this year, and we see a lot of chatbots that, despite the best of intentions, turn out kind of like my ISP's chatbot, which is like, can apologize very eloquently for not being able to do what I wanted to do. I think that there's a very good chance that we see AI ride down the other side of the hype cycle because of chatbots that can't do very much. And I think that would be a shame. I call it search. I call it recommendations. I call it digital assistants. I was actually having a fascinating chat with an AI researcher today who said, hey, Kyle, what you call search, like, we just call finding the answer really fast. Like, we can say, hey, we suddenly built an answer that when that answer wasn't public internet, when that answer was instead querying a series of enterprise databases, querying 280,000 documents that somebody has stored, for God knows what reason, when it's, hey, querying 4,000, in our particular case, like querying 4,000 or 5,000 code snippets, where exact text matching doesn't really make that much sense. Can we help people find the answers to things very, very rapidly? Can we help people find the answers to things before they even typed a word in that they were looking for, their form of recommendation? And then can we run this continuously? I think that this will really change. It'll raise the bar for the interfaces for enterprise products. You'll no longer have to remember the exact word when you type in something, when you're looking for something. You just the database is down. Let it take it from there. Figure out what I'm looking for and come back to me with all of the things that I'm looking for. Figure out what I meant to say. Instead of right now, wherever I see that search box anywhere, I just skip it.
I do the same, yeah. Okay, I got one more question. There are AI products all over the world right now being pushed. I think a lot of it's marketing spin. How can we as consumers sort of identify, what's the real value and what's just marketing spin on top of what isn't necessarily helpful? How do we make good decisions about purchasing products which are based on this new technology?
Look, the vast majority of, I think, of projects out there are using the LangChain library underneath or its moral equivalent. So let's use terms that show up in that library, because I think this should be pretty well known to people who are building on top of them, at least to somebody in the organization. Don't worry about snazzy natural language demos and ask a lot about capabilities. Okay, if I ask it to do something, how many somethings can it do? Can it do 4? Can it do 8? Can it do 20? Are they the same features that are available in the GUI? And now I'm just typing this, so it's kind of like the same set of features that I've always had. Or are there actually new capabilities, like truly new features that are really, really useful, that are being opened up by these things? So I do think that the level of industry sophistication is going to get there really, really, really fast. I don't think anybody's going to be impressed by a chatbot. Even now, I'm seeing backlash against that. I don't think anybody's going to be impressed by a chatbot in the coming quarter. And I think across our industry, more and more people have to use this stuff every day. We'll say, okay, so show me the word capabilities is the word. Show me the capabilities that this thing really has.
All right. Before we go, tell me about RunWhen Local, open source product. Which other?
All right. So I think you probably saw we're having kind of a moment. We launched this open source thing on July 7th, and I think as of yesterday morning, we just passed 700 downloads. I lost a bet internal. My bet was that we might hit 70 in July and August. And I was the highest count of anybody on our team, and we just did 10x that. So, I appreciate it. We're having a moment on that one.
And what is RunWhen Local? Is it like a system which you can install locally and doesn't require?
Yeah, so install locally. It does no calls to our backend. That was very, very important for us. Absolutely zero. So it's a totally standalone project. And credit where credit's due. This was my colleague Shay. This was Shay Stewart's brainchild. It was 100% his idea. It scans your local Kubernetes clusters. You can run it on a laptop. It just uses whatever kubeconfig or whatever service account permissions you give it if you're running it in a cluster. And it scans our authors libraries for troubleshooting commands. And it merges them together into this really nice cheat sheet that's got all of the troubleshooting commands, 70, 80% of them being kubectl, with all of the arguments all filled in, especially for big, ugly commands. Very often these things are 4 or 5 or 6 lines long. But you can just click to copy and paste. And for any of your app developers or for anybody that doesn't know Kubernetes as well, you can kind of just send them a link, and this has the documentation for what this command. This has some comments, inline comments about the command, and just say, hey, look, just copy paste this and run this. No looking up your namespace, no looking up your deployment. Just run it. So it's pretty fantastic for just a great big troubleshooting cheat sheet that takes very, very little, to your point, cognitive load to run any of the commands on it.
Well, there you go. If you were like me, like I was about 9 months ago, running a Kubernetes, application or cluster, then maybe give it a go.
Yeah.
Okay, thank you so much, Kyle, for coming back on the show for the second time to talk about AI. And it's a topic I know I'm skeptical about, so you're brave to come on. I wasn't particularly competitive today, but as part of it is because I don't understand it that well myself. So it's good just to hear what it's really about. And I think we got to the core a little bit today.
Finding the right use for the right tool. There are a lot of people that are overusing this tool.
Well, thank you once again for coming on the show, and thank you to everyone for tuning in. And I will see you all next week.
Thanks, Steve.